Alright, we're continuing with the graph of the logarithmic function in this video, and we're going to do the same stuff we've been doing in the earlier section. So if you understood our transformations from, I don't know, chapter 5 or something, I can't remember. If you remember all those shifts and transformations, then you're going to be in great shape for this. So we're going to do the same thing we've been doing. The first one was we're going to do a horizontal shift, and if you remember how that worked, we are kind of built with a minus. So it goes the opposite way of what you would think. A minus is going to move us to the right. So essentially we're going to take this graph of log base 3 and we're going to shift it to right. They're going to ask us for the domain, range, and the asymptotes. Now if I were doing this, the first thing I would do is I would try to remember 3 of x. Remember, they're inverse functions of each other. And so I would find the key points from 3 to x because it's much easier. Remember what we said, if you put in 0, you get 1. If you put in 1, you always get the b. Now, this is where I start, and I would then, the logarithm is the reverse machine, or the inverse machine, same thing. So that changes the domain and range. So these are my key points if I wanted to graph this. Okay, so let me let them help us here. So this is my initial graph of log base 3. I've got these 2 key points. If you want one more, you could pick any spot that you wanted. But so I've got these 2. That's good enough for me. I know it goes through here and it tails down along this asymptote. Because if you remember, the log function can never be less than or equal to 0. So I've got this asymptote here. I've used these 2 points to graph it. Now we're just going to go 2 to the right. So you could literally just move it 2 to the right on your picture, but if you wanted to make your points, if we're going 2 to the right, we're just adding 2 to each of those x values. So if you're on the graph, it'd be easy to just move 2 to the right. Okay, now what about the asymptote? Well, we had an asymptote at the line x equals 0. Well, obviously we've just moved it 2 to the right, so now it's at x equals 2. And if you were unsure of that, or if you wanted to ask the question about the domain, so we need x minus 2. So if we're asking the domain, where's the domain? We need x minus 2 to be greater than 0. It would break if it is not, so solving that I get x is greater than 2. So my domain is now 2 to infinity, and the range on these, if you did your ruler going up the graph, it's always everywhere. Okay, so we're going to shift 4 to the left now. So I would do the same thing. So it's always 0, 1. So I'm starting with the exponential because it's much easier to understand. Okay, then I'm flipping it. So reversing, I should say. I'm reversing the x's and the y's because the domain and range reverse. So we talked about this old video. Hopefully that makes sense. So here are my key points. Now, I'm going to take those points. Well, let's start with the graph. Okay, so I'm going to do this lightly kind of here because I don't have a lot of space. So here is my log base 3. Now, I'm going to move it 4 to the left. So 1, 2, 3, 4. Now I'm going to take this point here that's at 3, 1 and move them back 4, 1, 2, 3, 4, and now that's my new one. That really is good enough for me. As long as you had the domain and range, this would work for me. You could add a 3rd point if you wanted to be more precise. Okay, let's do the domain first. Our domain, remember, x plus 4 has to be greater than 0. So we're doing x is greater than negative 4. So my domain is then negative 4 to infinity. My range is always going to be everything. If you think about what's happening in this picture, it's going off in each direction. Doing my ruler, I'd be hitting something everywhere. And then how about my asymptote? It was at x equals 0. We moved it to the left 4. It's not going to be at x is negative 4, but that's also just always, it's always going to be that first number in your domain. You're doing the same thing there. So here's my asymptote, all my key information, and there's my new picture. Okay, we've done all this before too. Now we're going to tack something on the end, all the way at the end there. That's just taking the y value at the end and moving it up or down. So let's take a look. So we're taking that key log function, log base 3 again, and we'd be moving it down. So it does exactly what you would think it would do when you tack something on the end. It's just going to go down 2. Let me get to the picture. So we have those key points again. So remember it was 0, 1, 1, 3 when you looked at the exponential, but you reverse it. So here are the key points for the log graph, which they have marked, at least these two here. Okay, now we were going, I've forgotten what the equation is, we're going down 2. So you can make those points. We're going down 2 in the y, but if you have the picture, just literally go down 2 everywhere. Okay, now how about the domain? Well, we haven't changed. Where's the function? Oh no, this is not the right picture. That is not the right, yeah, that's not right. It should say this. That's what we're doing, moving it down 2. So our original function was log 3 of x, and then we're taking it down 2. Well, the domain is where we need this, what's inside of here, the x to be greater than 0. Well, that hasn't changed. We didn't do anything inside of there, so we have our normal domain for a log, which is 0 to infinity. Our range is always everything. We didn't move the asymptote. It stayed where it is, so the asymptote is at x equals 0. Okay, we're doing the same thing except we're going up. The only thing that's changed here is we've got 2 to the x, so I start with this. You probably don't need to, but I'm just in case it's unclear. This is the easy one. You put 0, you always get 1, because anything to the 0 power is 1. My second point is you put in 1, you always get the base. Now to do a logarithm, I'm going to reverse those like this. So here's my starting points. So I'm going to graph that. So here are my key points for my original function. Now we're just moving everything up 2. So he's going up 2, he's going up 2, and now here's my final function. And that really is good enough for me. I just want you to understand the transformations, so we're moving up 2. Now what about my domain? Well, what's inside of there hasn't changed. It's still x has to be greater than 0, so 0 to infinity. How about my range? Well, it still covers everything. And how about my asymptote? So our asymptote didn't change either, so we're at the original one, which is there's a vertical line at x equals 0. All right, time for stretches and compressions. So in that, when we did all of these in our previous chapter, we did horizontal stretches and compressions, but thankfully they're leaving that off, and I think it's for the best. But so we're just doing vertical stretches or compressions when there's a number out front. Well, it does exactly what you would think it does. It's going to multiply your y values by a factor of 2. It's going to stretch them. It's as if you grabbed the top and the bottom of the graph and you just pulled by a factor of 2 vertically. So, well, let's let them help us here. So we're doing log base 4. So I'll do this again here. Remember, that's what you would get if you did exponential. You can then reverse it. So here are my 2 key points. Now we're stretching it by a factor of 2. So we are going to multiply all the y's by 2. So this is, we're doing the logarithm, we're multiplying everything by 2. All of the y values are getting multiplied by 2, so I now have this. Now they did one more point, but it's right along the asymptote. I don't think it really gains us very much. So I have the point 1, 0 and 4, 2. I just connect those and I've got it. Now, how about our domain, range, and our asymptote? Well, the domain hasn't changed. It's the same. So it's still x has to be greater than 0, so nothing's changed there. How about our range? It's always negative infinity to infinity. And our asymptote didn't move either. We stretched this thing, but that's all we did. So x equals 0 is still my vertical asymptote. All right, we've got a half in the front here, so that's a compression now. It's doing exactly what you would think it would do. So I literally have to do this to think this through. So I'm doing as if I was doing 4 to the x. So I do this every time. Make sure I know what I'm doing. Okay, so here's what I would be graphing in the log. Now, we're multiplying the y's at the end of this. They're getting compressed by 1/2. What comes out of the function is getting compressed by 1/2. Well, if you multiply 0 by 1/2, nothing happens. But if you multiply 1 by 1/2, you get a half. So my new graph here, now it's at a half, so we've compressed it. Connect it, and that'll do it. Okay, the domain, well, we didn't do anything. X has still got to be greater than 0. The range, still negative infinity to infinity, it always is. And that vertical asymptote, we didn't do anything to change it, so it's still at 0. Okay, so we've got a couple things happening here. So just trying to think if I should go through all these steps. I guess I should. I'm going to abbreviate this here. So we go right or left first with those horizontal shifts. Then we do any stretches or compressions. I'm just going to abbreviate this. Okay, then we do any flips. So flips are coming up, I think, on a screen or two. We're going to do those too. And then finally we do any vertical up or down. So if you remember, these were the 4 steps in the order that we would tackle these when we were in the earlier section. Still applies. So first thing we're going to do here is we're going to go 2 to the left. And then we're going to stretch by 5. So let me see what they've got for us. Okay, excuse me, I have to sneeze and don't want to scare you to death. Okay, so this is a common log. So this is a log base 10. So if I were finding my points, I'm going to think of this as 10 to the x are going to be my starting points. So if I have 10 to the x, when I put in 0, I always get 1. When I put in 1, I get the base. So if we're flipping this around, here's what I'm graphing. These are the 2 points that I would want to graph. So yeah, that's this one right here in red. Okay, so we're going to go, first of all, 2 to the left. So here's my picture, going 2 to the left. And then after I've gone 2 to the left, I'm going to stretch it by a magnitude of 5, which is now the blue one. So what happens to the domain and range? Well, if you don't see it visually what you've done to the horizontal asymptote, just do this. X plus 2 has to be greater than 0 or this thing's going to break. So I'm going to do x is greater than -2. So that's my domain, which they've got for us here. Range is always negative infinity to infinity. The vertical asymptote is always that first number from the domain, and we've got it. Okay, so we've got 3 steps here. So we're doing the log base 10 again. So what were my 2 numbers? I literally have to always think it out. Okay, so this is I would be doing 10 to the x to find my spots. I then reverse them. Here are my 2 starting points. But what we're going to do is we're going to take that original log function, common log function, and this is first. We're going 2 to the right. We're then going to stretch by 3. And we're finally, we go up by 1. Okay, so it would be easier to do this with the picture. Now 10 is somewhere way over here. So this is the original common log function being graphed. Now we're going 2 to the right. The stretch is going to make this hard, but we're also going up 1. So let's do the stretch. So the stretch is multiplying all of the y values. So if these are my initial points, my new points are going to be 1, 0, because 3 times 0 doesn't change anything, and 10, 3. So you're only multiplying the y. You're only multiplying what comes out of the function. So x goes in just like normal. You multiply it by 3. So here are my new points after I stretch it, right here, and then we go up 1. So again, initially we go 2 to the right because of the -2. Now I'm going to stretch it, and then I'm going to go up 1. So yeah, I should do my final points. So if I'm going up 1, I'm now at, hold on, I'm going to do it down here. So I'm going up 1 on both of my y's. I've moved it up. Now you could usually just do it from the picture, but the stretch is making this a little complicated. So I'm going to mark, I'm going to start this all over again. So I'm now at 1, 1, and let's say 10 is over here. And there'd be my new one. Okay, domain. What is my domain? So I need x minus 2 to be greater than 0. So x must be greater than 2. Now I wasn't even, so I shifted 2 to the right, so I could have just thought it through. But if you're ever unsure, that's got to be greater than 0, so I'm going 2 to infinity. My range never changes, and my vertical asymptote is always that first number, but it's just that we moved it 2 to the right. Okay, so I'm going through this quick because we've done this all before. Remember, there are 2 ways we could flip the function. Well, maybe I go back here. So if you have the negative out in the front, you're flipping it in the y direction. You're flipping it vertically. So you're basically sending it down. If your negative is on the inside with the x, you're flipping it right and left. You're flipping it horizontally. So let's take a look at this. So we have the original function, and I see I've got a negative inside there with the x. This is a vertical flip. This is a right to left flip. So here was my original function. I've now flipped it over the y-axis. Now what would that do to my domain? Well, I mean, you could think it through, but this is what we're doing. Negative x now has to be greater than 0 because that's what's inside of there. So if I divide both sides by -1, x has to be less than 0 because I've divided by a negative with an inequality. So x has to be less than 0, that's this. My range is negative infinity to infinity, like always. My asymptote didn't change, but it's always that first number. Well, it's a little tricky because we're going the wrong direction, but that asymptote didn't change. It'll still be x equals 0. Okay, this is a little strange here, but so we're flipping twice here. We're going to flip it over. So this one is going to flip us over the y-axis, flip us left to right, and this one is going to flip us down. Like it's going to move us from vertically down under the x-axis. So here's our initial graph of the common log. So what we've done now is we've flipped this one. I don't think it really matters which direction. I'd have to think about that, but I think it'd be easier to think of it like, okay, first we went back, and then we flipped down. I'm trying to think of what that would look like here. I think that would be what would happen. You'd flip it down. So let me do it with the points to make sure I feel comfortable with this. So I've got 10 to the x, gets me 0, 1, and 110. Now I'm going to reverse those. Okay, now I've reversed them. So I'm going to put in whatever, I'm going to make these the opposite. I'm going to flip these, well, flipping it first over this way is going to change the y's. So I've now got 1 and like -0. That doesn't change anything. And I've got 10 and -1. And then to flip it down, now I'm going to change the x values. Hold on, is that right? Let me think about that. No, I thought I said that wrong, and I did. Okay, so here are my points for my log base 10, my common log. So if I'm flipping, this first flip is going to change the values of the x's. So I'd have -1, 0, and -10, 1. So this one is going to make all the x's flip to the other side. And then finally, by flipping it down, we're going to change all the y's to the other side. Now -0 is still 0. So I'd have this. So let me just see, -1, 0 would be there, -10, -1. Yeah, that's a good picture. Okay, so domain, range, and asymptotes. So the domain, all that matters is what's inside of here. I got to make -x greater than 0, x is less than 0. Flip the sign, divided by 1. So my domain, so this is the same as we just did if I went a little too fast for you there. But negative infinity to 0. My range is always everything. And what have I forgot? My asymptote. My asymptote didn't move. So we did a bunch of flips, but I haven't changed. I didn't shift anywhere, so it's still x equals 0. Okay. Yeah, this is just telling us, yeah, this is just summing up what we just did. But remember, so let me say this one more time, or I've got it back here somewhere. So this is the same as it's always been. If we've got multiple things to shift, we're going right or left first. We're doing our stretches or compressions second. We're doing any flips third, and then we're moving up or down. Okay, well, if you felt good about the previous version of the transformations, I think this should be pretty clear.